Hello mathematicians, we're now going to have a look at problems to do with maxima and minima of quadratic equations or quadratic functions. We're going to see later on that there's a better way to do this, I think, in terms of using calculus, but for the moment we're just sticking to quadratic functions to be maximised or minimised, and calculus will let us do these and a series of other equations as well. So in terms of what we know, we can see that if we're after the maximum or minimum value of a quadratic, what we're really talking about is the vertex. And we've got several ways to actually find the vertex. So we could use, as we saw in 8b, completing the square. So we complete the square and then read off the vertex. We can use the axis of symmetry, minus b on 2a. We can use factorisation, because if we can actually find the two zeros or the roots, then we know that the axis of symmetry is midway between these two. So this is not a problem. The use of the quadratic techniques for finding the axis of symmetry and hence the maximum or minimum value is generally not a problem. The problem is usually actually getting the quadratic function that we have to be able to find the vertex of. And this becomes a problem of understanding the question, which is usually minimised by drawing a picture, of making sure that we only have one variable eventually. So that may require that we have two equations and do a little bit of simultaneous solution, and eventually to write the quadratic, and that may require a little bit of algebra. Once we eventually have the quadratic in terms of one variable, then finding the maxima or minima minimum by finding the axis of symmetry should be a piece of cake. So let's have a look at a typical problem. I sometimes call these questions Farmer-Brown questions because most textbooks have a question in there about Farmer Brown. So Farmer Brown builds a rectangular chookyard using an existing wall as one fence. And she has 20 metres of fencing, and we've got to find the maximum area of the chookyard. So start with our diagram. So here's the wall. She's going to make a rectangular chookyard, and it said the length of the section of the fence that's parallel to the wall is something that we have to find. So how do we then start putting down some detail in this? So she has 20 metres of fencing. Let's just say that the length of this part here is x. Then this part here will also be x because it's a rectangle, and that means the length of this part here will therefore be 20 minus 2x. It's a piece of wire minus the 2 bits that she's used here. So identifying what it is that we want to maximise is key to these questions. So it's area that we want to maximise. So it's area that we want to get an equation for in terms of one variable. What is the area? The area is just length times breadth. X times 20 minus 2x, which we can see will be a quadratic expression. It will be 20x minus 2x squared. So once we've done that, we're really over the hardest part. So now we want to find, we can see that this is a parabola which is concave down, and we know that that parabola is going to have two roots, so we could, so obviously that's the path that I'm going down with my solution here. The two roots are going to be 2x outside of 10 minus x, so x equals 0 or x equals 10 are the roots. That means that the axis of symmetry will be at x equals 5. Because this parabola is concave down, then it will have a maximum value. That maximum value will occur when x equals 5. And when x equals 5, what is that maximum value? then it's what we get when we put 5 back into any one of these 3 equations. So if I stick it into this one, because it's probably the easiest, then that will give me 10 by 5. So the maximum value of this particular parabola is 50, and that is the area. So therefore, maximum area equals 50, and it occurs when x equals 5, and it's got units, so it's a real thing, 50 square meters. And the section of the fence parallel to the wall is going to be, on my diagram, 20 minus 2x, so that's 20 minus 10, so it's going to be 10 meters. Now the next one, 2 numbers have a sum of 6. Now it's being helpful here, it's telling you to let the 2 numbers be x, so if one of them is x, the other one has to be what's left, 6 minus x. And show that the sum of the squares of the 2 numbers is this. So this is just straight out algebra, the sum of the squares of the 2 numbers. So we want an x squared and a 6 minus x squared, that's our sum of the squares. We then work on that, so that's x squared plus, and then we've got expansion of a square, so square of the first minus twice their product plus the square of the second. So that gives us what we were aiming for, a 2x squared minus 12x plus 36. Now again, we can see that this is a concave up parabola, so it will have a minimum value. That minimum value will occur at the vertex. So now we find the vertex by whatever means we like. And rather than factorising this, I'm just going to say that the vertex is, so the minimum value will occur at the vertex, or at x equals, and I'm going to use minus b on 2a. So minus 12 over 4, so that's plus 12 over 4. So that means the minimum value occurs when x equals 3, and is, so the value of the minimum value, the minimum value is s. So I now just need to put 3 into, again, any one of these equations. And I'm going to go with this first one because I think it will be easier. So this is 3 squared plus 3 squared, so 9 plus 9, so 18 is my answer for this one. Will these questions in 8E get harder? Yes, they will, but the part that won't get any harder is finding the vertex. The part which will increase in difficulty is the algebra to set up the quadratic equation. And again, I would simply say go back to what was said earlier on, and that is make sure that you understand the question by drawing a diagram, writing the information down, and knowing that what you're aiming to get is an equation which is a quadratic and which only has one variable. Enjoy.